Yeah, there's a window coming. So this is my very, very small version of the internet. It has a glass martini and 2 exploits. So let's first look at the glass of martini. This is what no script is supposed to do, right? Like it prevents the shit from even executing. But if I choose to actually want to see that, it is loading Flash and it's taking, like on this shitty laptop netbook, it takes about like 9 seconds until I get my glass of martini. So this is, you can verify this is Flash by seeing the options that I don't see right now. Yeah, I don't have it on my screen here, so it's kind of funny. Is that the back button? Cool. So here's an in the wild exploit that for a relatively recent vulnerability. As you can see, I'm going to fire this. And so nothing happens on your side, but on my screen, which is the primary screen, I get a pop-up that looks like this. And it explains that this exploit didn't even bother to set the length fields in the first header, like the first length field ever in this entire file, to set that one right, which speaks volumes of like the Flash player parser, because that would be accepted. So you see 2 buttons. You can just hit escape and it disappears. But to the left there is also a button that says like tell the people they suck. Which sends us this lock, because if we filter the porn you really wanted to see, then you can complain by pressing this button. So, and then, you get a replacement file. You can actually configure the replacement file, so if you want to flip the finger at exploits, you can do that. Let me see. Back button? Cool. Here's another one. I actually had to figure out what the vulnerability was and write this trigger for the vulnerability myself. So this one actually cares about setting the length fields correctly. And here you see well, first I see it, a more concrete example of how far we go down. I'm going to mark this here. Yeah, well, I had to mark it first. So this is where we actually go down into the bytecode, and one of the individual bytecodes had an invalid argument, which will exploit the Flash player, but the format verification has caught it, and would have caught it before the vulnerability was found, because we're verifying the entire format. So this is what you get. Are you impressed? Now let's see if I can get this back to presentation mode. Awesome. Didn't work at Black Hat. So, now that you know what you get, let me explain how it works. So what is Flash in the inside, other than fucked? So, as I said, it's a container file format. But it is heavily version dependent. Every data structure in this file format is extremely version dependent, and the version is set right in the beginning in the header. So the file declares what version it is, which influences a lot of things, how the Flash player behaves, but also how the data structures look like. The problem with Flash, or one of the problems with Flash, is it's all the way backward compatible to version 3 of the file format. So, as someone said, trying to be backwards compatible is like trying to stay close best friends with all your ex-girlfriends, and we know how good that works. That's a real problem. I already mentioned that you can compress Flash files, but that really doesn't matter too much. In principle, the file format is composed of tags, and tags are simple type length value data structures like containers, in which then specific data structures for this tag type reside. A few examples of tag types. You have control tags, you have essentially like start and end the movie and set labels and bullshit. Then you have things that display objects, and we're going to talk about these more later. You will actually notice that those tag types here, they have something like, they have numbers behind them sometimes. So place object and place object 2 are 2 different tag types. In place object 2 actually doesn't place 2 objects as you would first assume, but it's their second attempt to get the data structure right. by the fact that we have a place object 3, you see how well that went. And that's a reoccurring pattern in Adobe's design, is like even opcodes have second and third versions. We also have bitmap data. You see there is a define bits JPEG 2 and 3. I don't know, like how hard can it be to not fuck up a JPEG data structure? But anyway, and they have a special tag type that is a button, which is nothing else than a shape, but it has functionality connected to it. Here's an example of a data structure. So they tend to lend themselves very nicely to buffer overflows and integer overflows because they have a shitload of length and counter fields, and they're all 32-bit long, and they can easily contradict each other by design. Which they, well, if you set, in this case, if you set one of the length fields on a negative value as marked out demonstrated in 2007, you can exploit the Flash player. One of the many ways you can do that. So what Blitzableiter does is what I call normalization through recreation. So we ensure we parse everything that we find in the greatest detail we can possibly do based on the specification. We're really strict on enforcing that all the cross-references and all the relations between length fields, pointers, indexes, all that are really, really completely tested and completely understood. Once we did that and could make sense of the porn, we throw away the original file and create new porn based on the information we parsed out. That has the benefit of providing perfectly clean porn to the Flash player, so you don't get owned. It also makes writing stable exploits a bitch because all the offsets change all the time. And that's essentially what we do, and that's essentially what I call normalization. How do we do that? So first of all, we're writing yet another parser for Flash, so we don't want to increase your attack surface. We want to decrease it, right? So we better not write the parser in an unmanaged language. We're using the .NET runtime to ensure that things like out of bounds and integer overflows will be called by our runtime and not by our code. If we would check for all the possible integer overflows in a file format manually in C code, we A, would fuck it up. Well, I most certainly would. And B, it would be a lot of code. Why would I do that? There is a runtime for that. It also means it runs nicely on Linux and BSD because it targets .NET 2.0, so it's perfectly binary compatible with Mono 1.2, which is currently shipping on most Linux platforms. And, you know, Mac users can kiss my silly ass. It was their choice when they bought it. So for all the TLV data structures that we have, not just the tags, but everything that is like type length and then block, we just move it into individual memory streams and operate on those memory streams, because then every out-of-bounds operation will actually throw an exception, and it does. The parser only accepts data structures that are documented in the Swift file format specification, which unfortunately is not very commonly updated. So if there is undocumented opcodes or any other bullshit going on, we're going to reject the file. And the parser also verifies all the version dependence, so you cannot claim to be a Swift version 6 file and then use some advanced functionality from version 8. Here's an example on why running on a .NET CLR is so cool. The exploit I mentioned before, 2007-0071 from Marked Out. If you're trying to read this into Blitzableiter, this is in the code where the actual exception is triggered for the negative value of the scene count. So the runtime caught it right there when we parse it. And that is fantastic. And this is what you get as an output later on. Let me tell you a little bit about the Adobe virtual machines within Flash. This is fun, and also a history lesson on how to not do stuff. So the Flash player actually contains 2 virtual machines, completely independent 2 virtual machines. They're respectively called AVM1 and 2. AVM1 is a historically grown thingy that they came up with in Flash version 4. And something about like 80% of the Flash on the internet are still AVM1. AVM2 is a virtual machine for ECMA 262 JavaScript specification, but of course the VM is completely by Adobe's design, which is not necessarily good. The AVM1 is programmed in ActionScript 1 and 2. That's what most web designers use, and ActionScript 3 is what is closer to JavaScript and is not so widely used in the I call them RGB Caspers, like people that make blinking web pages. So they struggle to understand OOP. So the whole JavaScript object and event handler idea just escapes them. So they stay with the AVM1. That's the reason why we have so much code there. So I said it was introduced in version 4 of the Swift file format. It was already a Turing-complete stack machine with variables and stuff, but someone must have left university after the first course because all the data, and like the only data type it could do was string. So if you would add 2 numbers, you would actually push 2 strings onto the stack, and then the add instruction will try to make sense of them to a number, and then add them, and then push back a string. In version 5, they realized that's a shitty idea, introduced type variables, and also introduced a constant pool. Someone must have made it through the first 20 pages of the Java specification. And they introduced objects and methods, which, is that good? Yeah. Which then in version 6, they discovered that objects actually need to be initialized before they run. So they introduced a tag type for that. And they actually, since they introduced versions, they now discovered that it would be cool to check they introduced types, and now it would be cool to actually check what type a variable is. So they introduced that. In version 7, then they added new functionality to their objects. For example, they discovered exceptions, and typecasting, and object inheritance. Version 8 never happened. I don't even want to know. And version 9 then brings in the AVM2 with a complete file format within the file format. So they have a complete new file format that is called the ABC file format that goes into one new tag type. And so you have yet another file format in the file format. And then version 10 is what we're currently watching the porn on. Now, keep in mind, this is all still supported. Back to the string editions. So where would you actually look for code within a Flash file? There's a tag type called doAction. Sounds like one. There's the majority of the AVM1 code is supposed to be there. And then there's the doInitAction tag, which I said is used for the initialization of objects, but can contain pretty much any code you want. Like, there's no restrictions that are put into place by the player. Then there's the buttons I already mentioned. So the define button 2 tag contains a button record 2 data structure that can carry conditional button cont actions, which is actually blobs of code. So you have a graphical element in a file format, a vector graphic element, and you attach a piece of code to it. Now, they obviously really liked this idea, then went back to their fridge with the psychedelic drugs, took some more, and specified the same behavior for shapes. So you can actually have 2 shapes, like a star and an asshole, and if they overlap, they clip. So clipping is when one of the shapes is not completely shown, for which you do clipping calculations. If those clipping calculations happen, the asshole can actually have code attached to it that is executed when it gets clipped. Isn't that nice? So you actually have to parse the entire vector graphics definition to get to the code that is executed when someone moves the mouse over it. Many security tools that we found and other tools actually don't parse that part of the code. They only parse the main part that is in the doAction tag. So you can totally smuggle code away. The code itself, like the AVM1 code, is variable length instructions. We all know how great those are. It has signed branch targets, 16-bit branch targets, which pose a problem. And then there's the 2 sickest things I've ever seen. So if you want to define a function in every other executable format,